So, hi guys, I'm Bruce. I run a company with, it's a micro studio with a guy called Jacob Keane. He looks like this. There's just me and him that run it, and we've started our company in January this year, but we've both been working freelance for multiple years together, like just sort of separately. So, one thing about me, I'm not always at my computer. I like to do other things, so I'm a kayaker. It's a big part of my life, so it's very important. So as well as making games, I also run the Northeast Games Network. It's called GameBridge. We've been running 3 years. We get about 200 to 260 people at that event. So it's quite big, and we run it every 3-4 months, depending on how it used to be monthly. It's now every 3-4 months, and there's a picture of GameBridge. I've worked on Sublevel 0, so if you were here for the first talk in this room, that was Luke and Gary. I worked with those guys. I helped them write some shaders and optimize their art workflow and things like that. I'm currently working on Gang Beasts at the minute. I'm currently helping optimize all the art to make that work. And while I'm also doing that, I'm making Babel, which is our VR game that's out on Steam. So this talk's kind of about a really ridiculous method of creating art and how we did it and why we did it, and then I go into details about general VR room scale development and problems we had and things that we avoided and things that happened. So first thing I'm going to say is what I'm going to talk about and what I'm going to show you is really, really impractical. For actual game development. It's really fun and interesting to do, okay? But if you're running it without running it as a texture, which I'll show you how to do, it's just kind of interesting and fun, which is why I wanted to talk about it. It's a little different, it's a little unique, but it's not something that you should run your game with. You shouldn't put this through because we'll go into why, basically, but there's a lot of reasons why. So, first things first, this is a trailer of our game, so
Thanks for applying to the Mount Olympus Temple Safety Bureau. I like the look of your application, so here are a few pointers. A deity in our line of work is to maintain the highest level of professionalism and requires the steady hands of a surgeon. I would also recommend doing your research. We have rules up here. Rule number 4, don't smash the towers. They are tributes, not toys, so please exercise self-control. There's Rule 27, respect the mortals. Somehow, this seems to have been a real issue for several previous candidates. Rule number 9, these are in order. If it looks dangerous, it probably is. So don't touch it. Seriously. This leads me to Rule 15. Always, always follow instructions. There's a reason they're given. Still think you have what it takes to make a name for yourself on Olympus? Well, let's get started.
So there you go. Thanks, guys. So it started out as a game jam game, Ludum Dare 33. It started out in the first day looking a bit ghetto. As you can see, this is basically how it ended up. If you look at those towers over there, you can see the sort of method I was going for texturing, because basically it ended up looking like this after 3 days. So the idea was to basically make a game where you play as a god and destroy a tower that humans have created, because who doesn't like destroying things, right? Everybody loves that. So this is just a really interesting outcome of gameplay that came out of that. The idea was to keep the totem alive. So basically the game loop is knock out bits of the tower until the totem at the top falls off, and that was the most ridiculous version of that we found. This is an early version of it in VR development. This is what it looked like when we got sent the Vive, and I was like, okay, right, we need to stick this on this and see if this works because it's interesting. So that was an early version. But we had 4 months from Game Jam to release to get this game out and running, alongside all the contract work that we were doing at the studio. So it was like you can only do this at certain times. So a lot of the stuff that I'm talking about and doing, we did and stuck with we stuck with that stuff because it's the stuff we did for the game jam, and it was just like, I'm going to keep this stuff because it needs to stay there because I don't have time to actually fix this yet, there's loads of stuff that I'm going to go through where we're going to fix it. So one of the main things that I really like about the game personally is the ability to smash everything up. So if you're making a Vive game and you can't smash anything or destroy anything, people don't really like. Everything has to have a physical interaction. So we made it so you could smash everything up, and then the bits of the tower that fall would land on tiny humans that walk around your feet, and they would turn into angels and fly to the sky. So I put this slide in mainly because we launched on early access the day the Vive came out, right? So we launched. It was cool. It's out. And then a couple of days later, we've had about 8 refunds so far. But I put this slide in because this is the tutorial level that you start the game in, and we got the best refund thing was a guy just went, yeah, I'm afraid of heights, so I can't play this. But this is the first level. We basically put you on the top of this mountain, and we call the mountain Tutorial Mountain. We have a joke about that in the game. So we're going to go back up to the game jam, right? So I said, let's do this game jam with textures, just model data and maths, right? Now, how many of you are into shaders? How many of you like writing shaders properly, like code them? Okay, how many of you guys do node-based shader editing? Cool. Right, good, because I purposefully made the textures in Shader Forge, so anyone that was watching later or that was in the audience, any artist could give this a go, because it's something that's just interesting and it's a good core concept to learn. Because it forces you to think outside the box with model data and the kind of information you get, basically, and how you can not use any textures, basically. But it's a stupid thing to do, so don't do it. So this is a texture generated with maths. As you can see, one of the cool things about generating any texture with maths is you get these really nice, defined lines and defined look. And if you put that across your entire game, it automatically looks cohesive because everything fits that world, the same world. It's all defined and working together in the way you wanted it to be. So I'm going to go in basically how to do that with the most. Well, before I do that, I'm going to do this. So how many of you guys are VFX artists? Are any of you VFX artists? Any of you dabble in VFX? A few of you? Okay, so in that case, there's a concept that VFX artists use quite a lot about using UV gradients to mask objects in and out depending on the time or place of that object. So we basically took that method that they use, that VFX artists use, and we were like, we're going to do that. So there are pros and cons to doing this. First thing is you have no texture lookups at all because obviously you're doing everything in shader. So it's just the shader going, I'm here, let's do this. You can go as close as you want to the object, and because it's generated with maths, the shader's generated with maths, you'll never get any texel. You'll never get any sort of low resness because you're going in and there's just there's no texels. It's just pure maths, and it's just like you can imagine vectors to look, but it works completely differently from vectors. It's procedural because it's all just numbers, so you can change it at runtime whenever you want, however you feel like. Just change it if that's not the way you feel. The cons. It's a per pixel calculation, and there's no anti-aliasing in the shader, so you have to do it on top, basically, as a post-pro, which most people do. But even then, it still becomes a bit rough, if that makes sense. It's still not exactly beautiful, if that makes sense. So it's a weird thing. And the problem is, as well, the more instructions you add to the shader, the more things you put into it, the more costly that shader is to run, right? So as the shader becomes more costly to run, you then, it just becomes an exponential performance hit, if that makes sense. The maths can get complicated. depending on, like I've just said that, that's cool. And it's all done in the 0 to 1 UV gradient space, so everyone's familiar with that. So that's what this is basically, that's showing. You've got your standard UV coordinates, and then if you split the red channel off from the green channel, you've got your 2 gradients, right? Everybody's familiar with that concept. Cool. So the first thing you do is generate a standard gradient, right? So there's the standard gradient. Next thing you do is you multiply that down to get the band that you need. So everything is created effectively fundamentally from this band, right? So then all you need to do is frac the band and scale it up. So the scaling is effectively your procedural parameter. That's the parameter that basically means that the shader is going to do exactly, that's what gives you your distance or your randomness for any shader. So this is the core fundamentals of what this method is. So then you take those two together, you duplicate it again, and you do it on, instead of doing it on Y, you do it on X, right? So then you have 2 bands going this way, and you blend them together, right? And if you blend them together, you get something that looks like this. But what you can do as well is you can multiply, add, subtract. You can do anything at this point and get all sorts of crazy, bizarre shapes, really interesting, defined looks. Like it's really dependent on how you feel about doing it or what it looks like, if that makes sense. So like it's more experimental than anything else. Like it's just kind of interesting to do. So then this is the bit where, because a gradient is like gradients don't have a defined art style or a look, right? So similar to doing like a multiply cell divide, divide thing, you can just posterize it, which gives you the same thing by an amount of steps, and that gives you this sort of a look. This is without any parameters changed. This is just a straight up standard look. And it looks okay. Pretty happy with that. Like it's going all right. So then you color it, and then like this isn't interesting enough, right? Like as a texture in itself, like defined as a texture, that's not an interesting thing to look at. But it is getting to a point where you can duplicate this shader out and make it cohesive, right? So what you need to do is take a small section of that shader itself, and you need to if out little bits of it. And you if out those little bits to get the detail bit, right? And then when you've got the detail bit, you need to, again, duplicate the same calculation with a little bit of difference, right? If you duplicate that calculation, it makes it feel a bit more like unique and wholehearted, but also it gives you the ability to add variance to all of it as and how you feel. So you can basically mix it up however you want to. And then you blend that back in on top of the actual original shader, and then you can do another one on top. So can you see how this is getting more and more complicated as time goes on? As the shader's getting complicated, the actual maths is very simple, but the shader itself is getting complicated, which costs and costs. So this is that shader that I just showed you. This is what it ends up looking like if you have variations, and you can make all sorts of different things with it. But like I said, the reason I wanted to do the talk is it's kind of cool, it's kind of fun, it's a really easy way to get into shader making. How many of you guys went to Andy Touch's talk about shaders? All right, okay, cool. So if you went to Andy Touch's talk about shaders, he did the full like strut bit, the Unity bit, and then the CG stuff, right? So what I just showed you is all the CG stuff that goes inside that and how to use it, but in Shader Forge. Like at the end of the talk, there's a download link to download the actual shaders, so you can have a look at them and poke around and do what you want with them as well. So this is one section of that whole shader, and as you can see, it's the same stuff duplicated, but it's a load and load of just like nonsense. Like it's just nonsense, right? But more importantly, to get this section here, where you've got the add and subtract over here, they give you diagonal lines. So diagonal lines add a lot more, it gives you another space, basically. And you can mess around with your fundamental starting lines to get any sort of pattern or shape that you want. It's really more, you've got to sit down and kind of just do it to get it working. It's kind of fun, it's kind of interesting. And as you can see, like I said, it gives you a really sort of cohesive look for the game and a really sort of quick look. So we chose to make the game like this. We chose to do this because we didn't have time to actively go in and change all the textures, and this was a fast way of getting the game done and out. But it's awful. Like, don't do it, guys. Just don't do it. So creating more complex materials, okay, this is where it gets kind of a little bit more different. You kind of like have to start thinking about model data. So like that doesn't look really like it was made like with one material, right? You look at that and you're like, what? That doesn't make any sense. What's going on there? So the way that's done is everything that I just showed you is applied to that. Is put in the shader, and then this is actually a load of model data. So it becomes more expensive on top of actually the standard modeling that you're doing because you're adding loads of verts everywhere, and then on top of that you're adding split verts, right? So every single one of these is a different vert and a different material ID, right? And that splits off your vert, so it increases your vert count for that one particular object. Does that make sense? Everyone following? Everyone understands vertex movement and stuff? So that's kind of a bit different and a bit crazy. And then all it is UV directly down, like flat and max. All it is both things, just UV'd flat. And then this is the calculation that we use to get the squares. So it looks like, if we go back, it looks like the actual tiled object, if that makes sense. So like it's what gives you all of these tiles. So that's using like model data and UVs, right? But you can also do this in world space. And now this is where it gets a little bit crazy because like using world space stuff and triplanar stuff. Is everyone familiar with triplanar? Does everyone know what that means? So triplanar is effectively XYZ slamming textures, sort of slamming your shader on all of the different coordinates so there are no seams and you can blend an object together. It's a quick way of putting a model in without having to really unwrap it or do anything with. Whether you just make the model, bash it in and go, this is the texture and it looks like this. Usually used for like gold and metals and stuff like that. So it's completely situational on the actual object that you're using. It gives you another axis to work from. So because the UVs are just X and Y, right? So you're just using an X coordinate and a Y coordinate. Whereas with this, you've got the Z component. And the Z component is another layer on top of all of those. And if you multiply those, it's then per world space object. So it becomes a little bit more complicated to get the look that you want because you're adding another axis, which means you have to add another collection of all of that data on top. And if you don't do that, it ends up stretching, and that's not really what you want to do. And it ends up looking like this. Like I'm sure all of you have seen similar things like this, where someone's just unwrapped a model and just planar'd it flat from the object, and you go around the corners and there's all this kind of data here, and you're like, what's going on there? That doesn't look good. What's that about? So you need to if you're using that, you need to avoid that. So because you're using world space objects, you have to avoid moving the objects up and down and rotating those objects. Because if any of those objects move, because they're in world space, the shader doesn't move. It just locks them in position like that. It just goes boom, and you're locked in. So you need to be careful of that. And matching the world space gradients to the object space gradients that you've already created is kind of difficult and interesting because world space is in one, like I said, it's got more axes, and on top of that, you've got all the other stuff below it. You've got all the, you've got it's a different form of math because you're using a 0 to 1 space, whereas in world space you're using 0 to 247, wherever the end of your world is, or wherever the end of that object is. So it's really hard to kind of match the scale of those objects. You need to look into that. Only use world space stuff on static assets, okay? Only use it on that. Like that's the only use. If you're using it on anything that moves, you're gonna have objects that it'll look weird. Just don't do it. And then if you're using UV coordinates, like I said, use it on dynamic objects. And like I said before, it's all based from 0 to 1 space. So you need to be careful about that. So how do you get around all of those like problems? How do you get around the fact that it costs loads and you're like, oh, well, it's just a massive shader, what do I do? So you can capture the actual shader itself as a texture. And this is like, it's kind of really ghetto the way that we do it, because like, I coded it, and as a technical artist, it's not really, like, Jacob was like, "No, what are you doing? This is rubbish. Sort it out." So first thing you need to do is set up a quad in a scene. In the download link that I've got at the end of this is all prefabbed up and set up for you. So you can just basically go and make stuff the way you want it and just slam it on there and hit play and it'll save it for you. But this is how you do it. You make a quad, scale the quad up. The quad's scaled up to like 5x5 for some reason. And then you take the camera and you make the camera orthographic, okay? And then when you've made the camera orthographic, you put both of those on the same axis, like x-axis at 0, 0, and then the camera's orthographic stand, because the camera goes from, the size of the camera goes from the center of the camera's position outwards both ways. So the camera's orthographic start is set at 2.5. So that's how you set that up. Then you write this. This is some code that's on that's like, some of it's from the Unity wiki and some of it's from like Unity answers. But this is the code that basically just takes the data that you need, takes the camera, takes a photo of it, saves it, and then saves it out for you. That's also in the download link. So like I said, you just have to run it. So now we're getting on to a little bit more like more like, you have to start adding other stuff on top of your shaders if you need them to work. So we needed to make the windows glow, right, without having an emissive channel. Like, we don't have any emissive, like any texture data, so we can't. How do we get around that? So we use vertex colors because that's the fastest way. But again, you're adding more data to your model than there needs to be, right? Does that make sense? So you don't want to do that because you're adding more information. But we did that, and that's some of what it looks like. And this is what it looks like in game. Jacob actually wrote a really took Sonic Ether's SS like bloom shader, if you've all seen that in the asset store, and then he took like how that renders it out at 64 by 64 instead, and blurs from that, because when you're actually in VR, how many of you guys are VR devs actually? All right, cool. How many of you guys have got Bloom working in VR, like at a stable rate? A few of you. So the way we did it was, like I said, Jake, we took Sonic Ether's shader and we basically dropped the bloom path that it takes out, because the actual headsets already blur the edges of corners for you anyway, and they blur bits for you. So you can use that to your advantage. And we managed to get like a pretty stable bloom working for us. That was quite good. So if you wanted to have a chat with me about that, my email's up, you can talk to me about that. So now we're coming to like the actual making the game and the interesting bit of how we we're away from all the gradient texture stuff and all that information. It's about avoiding UI and how we avoided UI making the game, because during the jam, because you're doing a game jam, nobody really wants to make a UI really for a game in the game jam. You just want to press space, like you just want one object that falls down, and it's all part of the physical world. It makes the world feel more realized, it makes the world feel more unique, and it makes the world feel different. So in the actual game, in the game jam game, you can pick up this object and slam it against any other object. You can smash everything up with it. So we wanted to keep this, right? But then there's a fundamental problem with keeping that as a thing. We can't push this. Well, I've already said that. So we needed to keep track of the score, right? But how do you keep track of the score in a VR game without having a HUD for the player? Because we don't have a HUD, right? So how do you keep track of that? So we put the score in the clouds, right? And we made one cloud model that's really kind of small and rubbish. And we basically made loads of letters out of them, like this. So we made a full like ASCII alphabet out of them, right? Which is kind of interesting, kind of fun, kind of different. And they're basically the clouds in the sky, right? So when you play the game, if you want to look at your score, you just look up. And we track where you are. So as you're playing the game, if you turn around here, the clouds like subtly fade over, like just go like this. And then every time you get an object or a score, Like every time you get a point, the clouds all blend together because they all use the same amount of individual small cloud models, which is the cloud model is the bottom of the question mark and exclamation mark. Like, it's that sort of a shape that we just build all of these out of. And getting that to work and run properly, getting those to dynamically batch was also a bit of a nightmare because they need to then be under a certain amount of tries, right? They need to be under 236 triangles, I believe, for them to actually batch together, which made it really difficult to make an object that you could rotate, move, and spin around and get it to look good. And then you're also dealing with all the random shader stuff. So it becomes like really complicated, as in like the game actually becomes really complicated for the computer to run before we get the chance to actually even get out there. So we ended up changing the score to make it fit the theme of the game, make it fit the Greek theme of the game. So we changed the score and it looks like that. So like I said, you just look up, that's what it looks like now. So we did this for level tips, right? Because our game is a puzzle game and there are loads of different objects you lift up, move around, and take places. We had to tell the player we had to communicate to players how to do that, right? So we had to go, what the tip for the level is, how you play the game, because we didn't really have the chance to do that. Because when you give someone a VR headset and go play the game, they go, what? Because they spend most of their time just running around flailing their arms going, this is amazing. So we had to tell players how to do something. We made signs, right? And they're awful. This is what they look like. These are terrible, right? These are the worst. These are the worst things. These never worked, right? But they're the iteration step that we had to get to the next step. So the next step was we went back to try and make the slabs like this, right? But as you can see here, this slab has the text inserted into the model, right? Which in itself is already loads more data than you actually need, and also ridiculously difficult to do if you wanted to do that. So instead, like the clouds, we generated what we call the rockabet, which is effectively just the alphabet again and ASCII letters that you need, but in 3D model form to fit the world and fit the defined shape of the way we needed it. And then from that, we created these small blocks like this, right? So we created these blocks, an end piece, a middle piece, and a start piece, an end piece, and a middle piece. And together, they fit together seamlessly. They all work together, right? So what Jacob then did was take those objects together and made a script. So you wrote the level description in a scriptable object for the game. So you were like, this is the name of the level, this is what the description is. And then and you hit generate, and it would generate from those models and the data that we had this sort of a block. And this was the first test that we did. This is what it looked like. And this is what it looks like now in the game. So these massive slabs fall down with the tower, and they're massive. You can't miss them. And they're just like, so people are like, oh, I don't know what to do. Oh, now I know what to do. It tells me. So you kind of get on with that in general as a whole. It was an interesting design problem as well, because it took a while for people to actually understand which bit of that they needed to talk about. For example, in this one, it says remove the 9 gold blocks. So you can only see remove the 9 gold blur. So we had to, from feedback we got, people didn't know that was the important bit, so they were just playing the game and we were watching people play it, and they'd smash everything up. So we actually ended up just making that section, the really important section, like bright emissive, so it like blooms out at you. So it's like as you're turning around, it's like, oh shit. So you can see loads of stuff. So that was also like a defined problem we had. We had a lot of problems with getting players to play the game because the whole of the game itself is defined so it's set up so you can run around and like most of playing the game isn't actually playing the puzzle game or doing the actual elements that are interesting. It's actually doing the like squishing the humans with a sword, or picking a human up and batting them across the room, or like trying to see how far you can throw them because you can pick them up, or picking up a block and just destroying the tower and resetting the world. and seeing what sort of elements or play elements you get out of that. So after we built the core fundamentals of the game, we spent ages trying to get those things to work, which was kind of difficult. So how many of you guys have actually worked with any room scale VR stuff? All right, okay, cool. So some of these problems you may have already faced. Some of these are just things, if you've not worked with room scale VR, these are things that we just had to deal with in the office. This is a photo of Jacob and Ant. So they both have an object. This is our office. They both have a Vive controller, and Jacob is shoving a sword in Ant's face in virtual reality, and Ant doesn't really know how to deal with it. And I'm kind of glad I captured this moment because it kind of defines like this weird middle ground that no one really, I've not really seen in games yet, which is other people can, while you're playing VR games, can come over and mess with you and you don't know that they're doing it, right? So that's just something that I think in the next game that we look into, I'm going to try and work something out for that, like design something in for that, because that's interesting, right? Because if you're playing a game with your friends, you can go and play that. So people get in the way, basically, is the point. All the time. Chairs, tables, you name it. Random dogs walking around the office, just constantly getting in the way. Like, you're walking around, there's a massive cable behind you, and you turn around and there's a wall in your face, and you don't know there's a wall because to you, there's a massive open expanse, right? And you're like, oh yes, open expanse, this is great. We actually had to put warning tape down in the office. So when we put warning tape down, it was like, this is the danger zone, do not go in this space, ever. So I would recommend that if you've got a few people coming to play test your game or play it in general. Okay, teaching new players to play your game is really, really, really interesting. It becomes, like, I'm sure everybody that's devved in VR already has found these problems, but if you want to teach a player to play a game in VR, it's not like they're picking up a controller and going, yeah, cool, I know exactly what all of these buttons do, right? They pick up a Vive controller and they're like, there's a touchpad, and I can do this. And then it becomes a lot of them just standing there doing, like, curling invisible weights, like, just going, this is amazing. So finding an actual way to teach players how to, to play the game becomes really interesting, and it can only be done on a game-by-game basis. And I don't really have any advice without looking at the game that you're working on. You have zero control when players are in VR of where they're standing or where they're looking. So if your gameplay space is here, right, you're like, this is where the game's happening. They can easily just do this and stare at a wall or stare at something else. So you have to spend a lot of time making sure that everything, all the lines, or the subtle hints, always point to the place that they need to be and where you're looking at, right? Or you can do stuff like this. So we put on the plinth that the objects fall in, we put this Greekish looking symbol thing, which is kind of fun. And players thought that they should go and stand in this. So what actually happened was players would walk over to this, stand in it, and then a tower would fall on them. And they're stood in VR with this tower on them, and they're like, what is going on? Because this tower's collapsed on them. No one knows what's happened. It's madness. So what we had to do was change it to this. We had to actually tell people. We had to go, right, you need to stand here. And make it really obvious. But even then, right, because this system that we used here, it's all around the plinth. And you'd think that a plinth is a thing that you look at and go, yeah, I'm not going to stand on that. But no, people see that and still go every now and then, I'm going to stand in the middle. So we had to make it so the game wouldn't start at all if you're stood on the plinth or you're stood in the middle, which is kind of fun, kind of interesting. It's always funny watching someone for the first time, though, have a tower fall on them. That's pretty funny. Also, stick googly eyes for your own amusement, guys, on your Vive headsets or your general headsets, because watching someone play test your game and having massive googly eyes just sort of float about and do all sorts of stuff makes it 100 times funnier. Thanks for listening to my nonsense. I hope you got something out of the talk in general. I hope the gradient texture stuff was useful. And if you've got any questions about it, feel free to email me, and this is the download link if you want to try it and capture it for yourself. You can feel free to do that. I hope you enjoy doing it. It's a fun thing to do with shaders.